In this video, you will learn Numpy, a very powerful library in Python that is widely used in the field of data science, machine learning, and in scientific computing. The Numpy library provides us support for large multidimensional arrays and matrices, along with a collection of mathematical functions to operate on these arrays. Here are some key features of Numpy. The first feature is its arrays. At the core of the Numpy package is the ND-array object that encapsulates n-dimensional arrays of homogeneous data types. So the arrays are basically n-dimensional objects of homogeneous data types. By homogeneous, it means that if you have items as strings or integers, all of the items of the array have to be of same type. The implementation of these arrays are in such a way that is more efficient than Python list for numerical operations. The next feature is indexing and slicing. In Numpy, you will have a lot of ways of indexing and slicing items from an array that are not available in Python list, and this makes it easy to extract subsets of data or modify specific elements. The next feature after indexing is broadcasting. So broadcasting is a technique in Numpy where it allows us to perform operations between arrays of different shapes and sizes. This feature makes it easy to perform element-wise operations on arrays of different shapes without the need for explicit looping or reshaping. After broadcasting, we have parallelization. Parallelization is performing operation parallelly. In Numpy, we can parallelize the operations because they are often implemented using optimized low-level libraries such as C that take advantage of parallel processing capabilities on modern hardwares. So these are the most important features in Numpy. There are more features and you are highly encouraged to explore them as well. Now let's see how we can create a Numpy array. In order to create a Numpy array, we have to import Numpy first. So here we are importing Numpy as NP, and then we call the array function of Numpy. In this example, we are creating a Numpy array from a Python list. This is a one-dimensional array because this list is one-dimensional. In this example, we are creating a two-dimensional array from a two-dimensional list, and this is an example of a three-dimensional array. If you run it, the arrays will be created. Okay, so the arrays are created. If you print first array, if you print it, you can see it's array and the items are here. Okay, the basic selections you have learned in list also work here. For example, if you want to select the first item, you select with index value 0. So if you run it, you will see the first item will be returned. Okay, and if you want to select from a 2D array, you have to give it two index values. The first one is for row and the second one is for column. Let's select from the first row. Let's select the first item, so it's 0, 0. Okay, so this is how we select. Now let's take a look into some of the key points about ND array and its attributes. First, let's learn axes. So in Numpy, arrays can have one or more dimensions, and each dimension is referred to as an axis. So if you consider this array, the first array, here we have only one axis. because it's one-dimensional array. In here we have 2 axes, in here we have 3 axes. So basically the number of axes depends on the number of dimensions you have. Many NumPy functions allow operations to be performed along a specific axis. So when you have multiple axes, you can perform operations on a specific axis. For example, if you consider this 2-dimensional array, here you have 2 axes. The one axis is for row, another axis is for column. So if you want to perform an operation on rows or column, then you can do so by defining the axis value in the parameter. Some common NumPy operations where axis is widely used are sum, mean, minimum, maximum, and etc. Next, shape. So the shape of an ND array refers to the size of the array. For example, a one-dimensional array might have a shape like this, indicating it has 5 elements along a single axis. For a two-dimensional array, the shape will look like this, indicating that it has 3 rows and 4 columns. Let's see some code here to understand it better. Here I have 1D array, and here I have a 2D array. Let's print the shape of the arrays. You can see that the first array has only 3 elements, and this tells us there are 3 items and just 1 axis. In this example, in this 2-dimensional case, we have 2 rows and 3 columns. So the shape looks like this, where the first number tells us how many rows and the second number tells us how many columns. So this is all about the axis and shape, and they are very important properties of NumPy array. A lot of time you have to be very careful when you perform NumPy operations. Okay, when we defined NumPy arrays, there was a term called homogeneous, and in there you learned that the data type of the NumPy arrays should be homogeneous, which means that you can have only one type of data in an array. Now let's see what data types are available in NumPy. Here is a list of data types, and they are very similar to low-level languages such as C. We have int 8, int 16, int 34, int 64. These are all signed integers with 8, 16, 32 or 64 bits. And then we have unsigned int 8, 16, 34, 64. These are all for unsigned integers. And then we have for float for floating point numbers, and we have complex 64 and 128 for complex numbers. We also have Boolean data type to store Boolean values, and then we have object. Object is a very generic data type, and we have string and Unicode data type here as well. This is a good overview of what data types you have available. Now let's see how you can specify the data type when you create a NumPy array. I have some example, I have some code given here. I will just copy paste them and run. So let's run this code first, and then I will explain. Okay, so in this example, we are creating array 1, and we are creating 2 arrays, array 1 and array 2, and we are defining the data type of the array in this way. We will use the dtype parameter, and then the value of the dtype can be either this or this. So you can say np.int32, or you can pass int32 as a string. Both of these will define the same data type. If you want to see the type of data, then you can print the data type by running this code. and you can see the data type is int32. If you are curious, you can also see for ARR2 you will have the same data type. Now what if you have already created an array with some kind of data type, or maybe it was created without specifying any data type. Now if the array has been created and you want to change it, you can use the astype function. So I have an array here. We will call astype on the array and specify the type that we want to change to here, and this will return me an array with the specified data type. Okay, so this array will have the items as this data type. Okay, so as you can see, I'm printing the data type of this, which is integer, and then I'm printing the data type of this, which should be float 32, because that's how we have changed.